All right, let's do some homework. Okay, question 4. The consumer will maximize utility by... Okay, so this is the picture that we are given. We have two indifference curves, U1 and U2. Mushrooms on the y-axis, spinach on the x-axis. I just need you to know that this drawing is a little incomplete. It's incomplete because I hope you can realize that you're looking at U1, which is below U2. So at U1, the utility level there could be 2. At U2, the utility level there could be 5, right? Now, remember, these are steep indifference curves. What do you mean? What do we mean when we have a steep indifference curve? Well, a steep indifference curve means that the individual or the consumer prefers the good on the x-axis and so would give up a ton of the good on the y-axis to get a little bit more of the good on the x-axis. Do you remember that from class? I hope you do. Those joining us from the YouTube streets, I do have lots of videos, that you could look at. So let's complete this graph. We can complete this graph by drawing higher indifference curves, right? Indifference curves. So here goes the third indifference curve. U equal, let's say, 7. Now, if you notice, if you look at indifference curve, the first indifference curve, U1, it is intersecting the budget constraint. To find where the consumer is maximizing utility and so is consuming the optimal bundle, we have to see tangency between the indifference curve and the budget constraint, right? Yeah. So even at U2, we do not see any tangency. We see an intersection, and that's not what we're looking for. We want tangency. And so for those of you who are speeding ahead, I hope you can see that tangency will be exactly here at the corner. Let's say U equal 10. U4, and that's U3. Okay, U4 equal 10. Or U4, U4 equal 10, and U4, that indifference curve, is tangent to the budget constraint at the corner where the consumer will maximize utility by consuming 8 units of spinach and 0 mushrooms. All right, so this is the optimal bundle. The optimal bundle, again, occurs at tangency between the indifference curve U4 and the budget constraint, the blue line. Okay, moving on to another question. Spend all income on good X and good Y and assume price of good X increases and income increases. Okay, we are given two scenarios where in one scenario the price of good X increases. We can use that scenario to deduce what happens to the maximum units of good Y that one could buy and the maximum units of good X that one could buy. Right? When the price of good X increases, the consumer will substitute away from consuming good X and towards good Y. So you can expect that the consumption of good Y will go up and that of good X will fall due to the substitution effect, right? Due to substitution effect, SE. Due to SE. And what is the substitution effect? Well, when the price of good X increases, the consumer will substitute away from good X because it is now relatively more expensive and buy more of good Y because that is now relatively cheaper. Now when income rises, just look at Y. Y equals the maximum units of Y that you could buy is equal to all of your budget divided by PY. Now, the budget increased, right? Income increased. Some books use B, other books use I. But when income increases, your budget increases. And so when B increases, Y gets bigger. So Y goes up because B1 got bigger. Now, with X is also equal to B1 over PX, right? Now, when B1 increases, X will also increase because B1 got bigger. Okay, now we can combine these two effects and see what happened to both goods. Well, for Y for sure went up. So Y went up because in both scenarios, we notice that well, Y went up. And so Y definitely went up. Now, for X, in the first scenario, when the price of X went up, the units that one could purchase went down for X. But in the second scenario, when income increased, the units that one could purchase for X went up. So which of these effects dominated? We don't know. So ambiguous. Well, so what is the conclusion? The conclusion here is that the units that the consumer could purchase of good Y has increased, right? So this is coming from a multiple choice question. And the choice that one was to pick as the answer is the amount of good Y that the consumer can purchase increases, and that is for good Y. Okay, for students joining us from YouTube, there's this additional equation here. What is this equation? Well, this is the budget line. This is how we depict the budget line, right? That budget or income equal the expenditure that you're making on good X and good Y, where you take the price of good X, multiply it by good X, plus the price of good Y and multiply that by good Y, right? So we are saying your expenditure has to exactly equal the budget or the income that you are given. I have other videos if people are interested to take a look. Okay, next question. This is also coming from a multiple choice question, but I want us to take just the question and work our way through it to see what the conclusion is, right? So we have a consumer J spending all their income or her income on groceries and movies. So there is some income that already exists in consumer J's pocket. Now, option A, consumer J is going to get a voucher, some cash, and she'll be restricted in option A to spend that cash only on grocery. Option B, the consumer will be given some cash, X, that they can spend on grocery or movies or both goods. Now, the consumer prefers A to B, and we're going to see why that is so. Okay, so let's work through this and draw the budget constraint or the budget line for both options, right? So I'll walk us through these. Now, before we do that, let's go through some thought process here. Let's start on option A. Okay, to draw this budget constraint, and I'll set that goods space out. I'll set it up here. Let's put groceries on the y-axis, groceries on the y-axis, and let's put movies on the x-axis, movies. Okay, now option A. What is the maximum groceries that this consumer can buy if they bought no movies? Remember, the consumer has all her income, and under option A, she gets an additional voucher, some cash to spend on only groceries, right? So the maximum groceries that this consumer can buy if they buy no movies. So max groceries if buys no movies. If buys no movies will be, well, her voucher, right? Maximum groceries, her voucher. She can only spend the voucher on groceries under option A. So will be the voucher X dollars plus her income, let's call that I, divided by the price of groceries. Okay. So that's one of the points on here. I'll keep that in blue, right? So that's I plus, well, X plus I. I want to keep things consistent here. So X plus I divided by price of groceries. Okay. And here's another thought process. What is the maximum number of movies that this individual or this consumer can buy if they bought no groceries? So maximum movies if buys no groceries. So groceries, spending everything on movies. Well, her voucher is supposed to only go to groceries. So we can't touch the voucher for movies. And so the maximum number of movies she can buy if she buys no groceries will be just the I divided by price of movies. And I will write that down here. It will be her in blue, right? It will be her I divided by price of movies. So I'm writing this on the graph to your right hand side. Okay. There is more. If this consumer spends all her income I on movies, that means she can only spend all the voucher on groceries. Yes. So the maximum groceries if the consumer spends all income I on movies. This means she will only have the voucher left. The voucher is X, so let's write X. She's going to spend all of her X on groceries. So where do we write that? How do we show that on the graph? Well, if the consumer, I'm on the graph now, right? The graph is to your right hand side. If the consumer is spending all of her income I on movies such that she's left with just the voucher to spend on groceries, this is what we will draw. This is how we will draw it. And so you can see that there is a kink in the budget line that we just deduced out of option A. So let's draw it. So it has three points. There are 3 points to connect here. So that's the first one. 0.1 along the grocery axis, 0.2 out here in the middle of the graph, and then we connect the rest of it. This is the budget constraint under option A. Okay. Under option B, and I'll squeeze it out here in red, that way we still have our view of all the information that we need. Under option A, the maximum groceries that the consumer can purchase, what would that be? Right, this is a good place where you can pause the video and try to work it out on your own. But well, under option B, and I'm writing this in red, under option B, this consumer has the voucher and her income, and she can spend the voucher on both goods, right? So the maximum groceries to buy will be X plus I divided by PG. Oh, we already have that. Yeah, we do. So I'll put a red mark on the y-axis, right? Just a smidge above the blue dot on the along the y-axis. Okay, now what about the maximum movies to buy? Well, the maximum groceries to buy if buys no movies in the first one, right? If buys no movies. And in the second one in red, the maximum movies to buy if buys no groceries. Well, that will be X plus I divided by price of movies. And so that is right here. I'm running out of space. X plus I divided by PM. So what I'm going to do here is to connect the two dots. The first dot is on the grocery axis and the second dot is on the movies axis. So I'm just going to connect these two, and yes, we'll go by the kink from option A. So how about I just try to do it like that and join the rest or the remaining points. Now I'm joining them gingerly above the blue line so that you can still see the blue line. There's no space between them. I'm just joining it like this so you can see both colors. Okay. There's additional information in the question. The additional information is that consumer J prefers A over B, and we can see, I hope you can see why. That there is this unique portion which I am shading in polka dot red. There's this unique portion which gives the consumer more what? Well, more movies, right? Fewer groceries, but more movies. So the conclusion here is that, oh, hold on a minute. Oops. Right, this is the point of the voucher, but okay. The consumer prefers option B to option A because under option B, she gets that red polka dotted area. And in that red polka dotted area, what is happening? Well, in that red polka dotted area, she's spending less and less of the voucher on groceries. Do you realize that? Like right here, right here, she's spending less than X on that point, right? Let's call that point W. She's spending less of the voucher on that point. On this point right here, let's call that point Z. She's spending even less of the voucher on that point, and she's getting more movies, right? At W, she's getting more movies. Now let me clean this up and go over it again, because I realize my polka dots, there are too many. Right, let's take this again. What is happening in this extra piece that I had colored in red polka dots? What is happening there is, take a point in that extra piece. Let's call that point W. At W, the consumer is spending less than the voucher, right, on groceries, and spending the extra on movies. Take another point Z. This time let me use black. Point Z, the individual is spending even less of the voucher X on groceries, and spending the extra on movies. Do you see? So the conclusion that we have to draw here is, yes, consumer J prefers B to A, and she prefers B to A because option B allows her to have this area I have now shaded in black, because it allows her to spend less, right? Consumer J spends less than the voucher, and the voucher is X dollars, less than X dollars on groceries, and that extra is spent on movies. So this is why she prefers B to A, or this explanation matches her preference of B to A. I hope this helps. If it doesn't, please come to office hours or drop a comment in the comment section